In the heart of a quiet laboratory beneath the Swiss Alps, a machine hums softly, listening to the language of neurons. A human brain, preserved, cooled, and meticulously sliced, is being scanned, layer by layer, at the highest resolution ever attempted. Billions of connections, molecular signatures of a once-living mind, are digitized into a structure of pure data. This is not science fiction. It is a real experiment, funded by real money, and driven by a dream older than myth itself, to transfer human consciousness into a machine, to break the biological chain, to conquer mortality by encoding the mind. Is it possible? To answer that, we must begin not with machines, but with minds, with consciousness itself. What is consciousness? Philosophers have struggled with this question for millennia. The ancient Greeks believed the soul resided in the heart. Descartes placed it in the pineal gland, calling it the one thing he could not doubt. Cogito ergo sum. I think, therefore I am. But that famous certainty does little to explain what consciousness actually is or where it resides. Modern science tells us the brain is the seat of consciousness. But this is only a partial answer. For even with our fMRI scanners and EEG waves, we still cannot pinpoint exactly how subjective experience arises from objective matter. This is what philosopher David Chalmers calls the hard problem of consciousness. How do physical processes in the brain produce the rich inner world of thoughts, feelings, and sensations? Neurons fire, synapses strengthen, chemicals flow, but none of this explains why it feels like anything to be you. And yet, if we are to believe that consciousness can be downloaded into a computer, we must believe two things: that the mind is entirely physical and that it is possible to recreate those physical processes in another medium. The first belief, that the mind is physical, is the foundation of a materialist worldview. According to this view, every thought, memory, and personality trait is a result of physical interactions between neurons. Consciousness is not a ghost in the machine. It is the machine. If this is true, then in theory, it should be possible to replicate the machine. In practice, the challenge is immense. The human brain contains approximately 86 billion neurons, each connected to thousands of others, resulting in over 100 trillion synaptic connections. These connections are not fixed. They change constantly in response to experience. They are weighted, chemical, and context-dependent. To download consciousness would require not only mapping the static structure of every neuron, but also the dynamic state of the entire system at a given moment in time. This includes ion channel distributions, neurotransmitter levels, epigenetic markers, and even glial activity. It is a feat akin to mapping the weather patterns of every square inch of Earth down to the molecular level and then simulating it perfectly. And yet, some believe it can be done. Projects like the Blue Brain in Switzerland, the Human Connectome Project in the United States, and the Allen Brain Atlas have already begun the monumental task of charting the brain. Using powerful electron microscopes, researchers have mapped cubic millimeters of mouse brain at nanometer resolution. The data is vast, petabytes for mere fragments. But mapping structure is only the first step. The second step is simulation. Once we have the connectome, the complete map of neural connections, we must simulate how those connections produce thought. This is where computer science meets neuroscience in a dance of staggering complexity. To recreate a mind, we need not only a map, but a model, a set of rules that determines how signals propagate, how memories are stored, how consciousness emerges. Can a computer do this? In limited ways, it already has. Artificial neural networks, loosely inspired by the human brain, have learned to recognize faces, translate languages, and generate art. Large language models can hold conversations, write stories, even simulate philosophical reasoning. But these systems, for all their brilliance, are not conscious. They are imitation machines trained on patterns devoid of self-awareness. Still, they hint at a future where computational systems approach the sophistication of the human mind. One proposed path to consciousness uploading is whole brain emulation, WBE. This approach assumes that if we can scan and simulate the entire brain at sufficient resolution, the resulting model will be conscious, because it replicates the structure and function of the original. This is the path imagined by many transhumanists who see the biological brain as obsolete. To them, the mind is software, the body is hardware. Upgrade the hardware, and the mind can transcend its fleshy prison. But this analogy is flawed. Biological brains are not like digital computers. They do not process information in discrete bits. They are analog, wet, noisy, and deeply embodied. The way your brain processes pain, for instance, is tied to your nervous system, your hormonal balance, your gut bacteria, even your immune response. To truly emulate a brain may require simulating not just the neurons, but the entire body. And then comes the philosophical problem. Even if we could create a perfect simulation of your brain, a digital twin that thinks, speaks, and behaves exactly like you, would it be you? Or just a copy? Imagine you undergo a brain scan so precise that every synapse, every molecule of your brain is captured and reconstructed in a machine. You wake up and find yourself still in your body, but on a nearby screen, a digital version of you is speaking, reacting, remembering. It insists it is you. Who is right? Philosophers have long wrestled with such scenarios. Derek Parfit, a British thinker, suggested that personal identity is not what matters. What matters is psychological continuity. If your thoughts, memories, and personality persist, then in a meaningful sense, so do you, even if the original body perishes. Others disagree. They argue that the sense of self is tied to a continuous stream of consciousness. If the stream is interrupted even for a nanosecond, then a new self begins. In this view, uploading the brain does not preserve you. It merely creates a convincing replica. And then there is the issue of qualia. Qualia are the raw, subjective experiences of consciousness, the redness of red, the bitterness of coffee, the ache of nostalgia. Can these be simulated? Can a machine feel? No one knows. There is no test for consciousness. We cannot open a black box and see if it experiences qualia. We can only infer it from behavior. This is the basis of the Turing test. If a machine can imitate human behavior well enough to fool us, we might as well treat it as conscious. But imitation is not understanding. The Chinese room argument proposed by philosopher John Searle illustrates this. Imagine a person in a locked room with a book of Chinese symbols. They receive Chinese characters through a slot, look them up, and send back the correct responses without understanding a word. To an outsider, it seems like the room understands Chinese. But does it? Is simulating consciousness the same as having it? Again, no one knows. And yet, despite these doubts, the pursuit continues. In Silicon Valley, startups like Nectome claim they can preserve your brain for future uploading. The catch? The process is fatal. You must die for your brain to be perfectly preserved. Critics call it assisted suicide disguised as science. Supporters call it the first step toward eternity. Others explore non-invasive methods, brain-computer interfaces that learn your thoughts, habits, and memories while you're still alive. Over time, your digital twin grows more accurate. Perhaps one day it could replace you entirely. But this raises a chilling question. If your digital self can live on after you die, what happens to your rights? Could your consciousness be owned, hacked, or enslaved? Could you be copied, sold, or deleted? In a world where data is currency, what does it mean to be human? There are other, stranger possibilities. Some theorists speculate that we are already digital beings, that consciousness arises not from biology, but from computation. According to the simulation hypothesis, we may be living in a virtual universe created by a higher intelligence. If that's true, then uploading our minds is not creating something new, it's merely changing operating systems. And if we can upload, can we download? Could consciousness migrate freely from one medium to another? Could we one day beam our minds across the stars, inhabit robotic bodies on distant planets, or live inside fully immersive virtual realities? Would we still be ourselves? Or would we become something else entirely? The path to digital consciousness is not just a technical challenge, it is a spiritual and existential one. It forces us to confront what it means to be alive, to be self-aware, to be you. Will we one day download the mind? Perhaps. But even if we can, we must ask, should we? Would eternal digital life be a paradise or a prison? Would consciousness, freed from biology, still be human? Or would it evolve into something unrecognizable? The answers lie in the future. And the future, as always, is watching.